the biggest cosmic encounter since Oumuamua, and honestly, the world's most powerful space agencies have gone completely dark. On October 3, 2025, an interstellar comet named 3I Atlas buzzed Mars, and the only proof we have is a ghostly smudge found by citizen scientists in public data. With billions of dollars of technology pointed right at it, the official images are missing in action. So, are we looking at a cover-up, a colossal failure, or the quiet prelude to a discovery that will change everything? Let's explore this together. The flyby. So, what really went down on October 3, 2025? Imagine an object born in the dark between the stars, wandering for millions of years, finally entering our solar system. This visitor, 3I Atlas, made its closest pass to Mars at a distance of just under 0.2 astronomical units. That is about 29 million kilometers, close enough to give us the best look we have ever had at an interstellar object. This wasn't some distant blurry dot. The comet was right in the neighborhood of our most advanced robotic explorers. Experts like Dr. Casey Leese have spent their careers waiting for a moment like this. In response, a fleet of spacecraft was mobilized. NASA's Mars Reconnaissance Orbiter, the European Space Agency's Mars Express, the UAE's Hope Probe, and China's Tianwen-1 all had their schedules scrambled. Mission planners worked overtime, recalculating trajectories to point their instruments at this fleeting target. The comet was moving at a speed no solar system object could match, a ghost passing through the Martian sky. The opportunity was historic, but it was also incredibly brief. The promise of Mars. This was never just about getting a cool picture. This alignment was a once-in-a-generation chance to answer some of the biggest questions in planetary science. Having a world-class laboratory already in orbit around Mars meant we could study 3I Atlas in ways impossible from Earth. Think about it. The Mars Reconnaissance Orbiter's high-rise camera could potentially see the comet's nucleus or any fragments breaking off. Spectrometers like Omega on Mars Express or the Nomad instrument on the Trace Gas Orbiter were ready to taste the comet's atmosphere. Dr. Nicholas Thomas, who leads the team for the CASIS camera, knows these instruments are sensitive enough to detect the unique chemical fingerprints of interstellar ice. Are the building blocks of life the same in other star systems? Is the water in this comet similar to ours? These instruments were designed to answer exactly those questions by analyzing the gases in the coma. It was a chance to perform a chemical autopsy on a pristine sample from another star system, testing every theory we have about how planets are made. Every asset was pushed to its absolute limit for this cosmic flyby. A faint signal emerges. With the world's major space agencies completely silent, the first piece of evidence came from where nobody expected it, the public data archives. Working independently, two citizen scientists known for their meticulous work processing raw space images made the first confirmation. One of them was Kevin M. Gill, a software engineer at JPL who is famous in space circles for turning raw data into art and science. They downloaded the public Mastcam Z images from the Perseverance rover just hours after they arrived on Earth. The process was painstaking. They took dozens of long-exposure images of the Martian night sky, carefully aligned them using the background stars, and then used complex algorithms to subtract the immense noise. And then, they saw it. At the exact predicted coordinates for 3I Atlas, a faint, diffuse patch of light emerged from the static. It is not a dramatic photo. It is a subtle, slightly smeared glow, but it is real. They released their findings cautiously, sharing their annotated images and the code they used so anyone could verify their work. It was a testament to open data and persistent curiosity. The auditable path. Seeing a faint smudge in an image is one thing, but proving it's actually an interstellar comet and not just, say, noise, is a whole other challenge. The path to this detection had to be fully auditable, which means every single step was carefully documented and reproducible. The analysts started with raw 29-second exposures from Perseverance's Mastcam Z camera. The principal investigator for this camera, Dr. Jim Bell, designed it for, honestly, incredible scientific precision. For each image, a T-ratio R-browser R-derby and omichinrostans ambassadorium. Hard-showing had to find a matching dark frame, that's an image taken with the lens cap on, to map out and subtract the camera sensor's own electronic noise. Then flat field corrections came next to account for dust on the lens and any variations in pixel sensitivity. After that, they had to align, or register, every image with sub-pixel accuracy against a star catalog. Only then could they stack the dozens of cleaned frames together. They actually used multiple methods to combine these images, which boosts the signal of a faint object while averaging out random noise. The final step? Modeling and subtracting the Martian sky's background glow. What was left was the detection, a signal statistically strong enough to be real. This wasn't guesswork, it was a forensic process start to finish. Viral myths and reality checks. The moment the legitimate faint signals started to circulate, the internet did what it does best. It found fakes that were, well, way more exciting. The most viral was this sharp, bright streak in a Perseverance Navcam image from October 3rd. People claimed it was the comet, clearly visible and dramatic. But seasoned analysts immediately got skeptical. Planetary geologist Emily Lakdawala, who's known for her forensic checks of space images, ran the numbers. She plugged the image time and coordinates into JPL's Horizons system, which is really the gold standard for locating objects in the solar system. The streak's path, speed, and timing matched Phobos, Mars's inner moon, caught during a long exposure. Classic case of mistaken identity. Another claim focused on a different bright streak, but analysts quickly showed it was moving at least 10 times faster than the comet's predicted speed across the sky. So, it was likely a meteor, or maybe even a cosmic ray, hitting the sensor. Emily and others methodically debunked these claims, showing side-by-side comparisons of the fake streaks versus the comet's actual predicted path. The lesson here is pretty clear. In the age of instant analysis, rigorous verification matters more than ever. The silent orbiters. So, where were the multi-billion-dollar orbital missions while citizen scientists were making the only public detection? The silence is honestly what makes this story so strange. Let's be clear about what we're missing. The Mars Reconnaissance Orbiter carries the HiRISE camera, a telescopic instrument so powerful it can spot a coffee table on the Martian surface from 300 kilometers up. Its principal investigator, Dr. Alfred McEwen, and his team could have delivered the sharpest image of an interstellar object ever seen. The ESA's orbiters were ready to perform a chemical analysis. The Trace Gas Orbiter can detect atmospheric gases in trace amounts. If 3I Atlas was venting anything unusual, any molecule not seen in our own comets, it would have found it. The UAE's HOPE and China's Tianwen-1 were also observing, providing a global network of coverage. The potential for a breakthrough was immense. Yet, as of today, not a single raw image, spectrum, or even a low-resolution thumbnail has been released to the public. The data is either under embargo, stuck in a processing queue, or, well, maybe something else is going on. The knife's edge. Pointing a deep space orbiter is not like using a DSLR. It's, really an exercise in calculated risk, operating on what engineers call the knife's edge. The predicted position of 3I Atlas, its ephemeris, was constantly being updated. Each orbiter had to be slewed, or turned to point at a patch of empty sky, just hoping the comet would arrive on schedule. There's no real-time joystick. The commands are sent hours in advance, and the spacecraft executes them autonomously. It is, honestly, a leap of faith. The entire observation might hinge on a prediction that was off by just a fraction of a degree. Then there's the Deep Space Network, the communication lifeline to Earth. According to Dr. Lori Glaze, NASA's head of planetary science, bandwidth is a precious resource. All of NASA's Mars missions plus international partners have to share time. So even if an orbiter captured a perfect image, that data might sit in its onboard memory for days, waiting in line behind higher priority health and safety telemetry. A missed pointing window or a delayed downlink could mean the difference between a historic image and a frame full of empty space. Blinded by the sun. Just as the mystery of the missing data deepened, the curtain came down on any new observations from Earth. And you know, this isn't a conspiracy, it's just orbital mechanics at work. As October advances, 3I Atlas is approaching what's called superior conjunction, when it passes almost directly behind the sun from our perspective. This celestial alignment, happening around October 21st and 22nd, effectively blinds us. The sun's overwhelming glare makes it impossible for any ground-based or near-Earth telescope to safely observe the comet. The comet's most active phase, its closest approach to the sun, or perihelion, happens on October 29th, right in the middle of this blackout. As Dr. Michael S. P. Kelly has noted in his research, this is the most critical time to observe a comet for outbursts. It's when the comet should be at its most dynamic, and we are completely unable to watch. This blackout will last until early December, so for now, the silence from the Mars orbiters is compounded by a physical barrier. The universe itself has blocked our view, leaving us to wonder what is happening in the glare. The working hypothesis. Before the data blackout and the mysterious silence, what did scientists actually think 3I Atlas was? Based on early observations, a working hypothesis had formed. The evidence suggested it was a natural interstellar comet, not an artificial object like some had speculated about Oumuamua. Its behavior was broadly comet-like. Analysis of its light signature pointed to a composition rich in carbon dioxide gas. What was more interesting was what seemed to be missing. Like the previous interstellar visitor 2I Borisov, which was studied extensively by scientists like Dr. Dennis Bodowitz, 3I Atlas appeared to be depleted in dicarbon. This is the molecule that gives most solar system comets their classic green coma. Its absence suggests a different chemistry, born in a different kind of stellar nursery. Some early unconfirmed spectra even hinted at an excess of certain metals, like nickel. But all of this remains provisional. Without the high-fidelity spectra from the Mars orbiters, this hypothesis is just an educated guess. The final word on the comet's chemistry is locked away in the very data we are all waiting for. What remains and what comes next? The data from the Mars flyby might be out of reach for now, but the story is not over. There are a few long-shot possibilities for observation during the solar conjunction blackout. The SOHO spacecraft, which constantly stares at the sun, has a coronagraph called LASCO C3 that might catch a glimpse of the comet. It's not very sensitive, so it would only see 3I Atlas if the comet had a major outburst and brightened dramatically. Farther out in the solar system, the European Space Agency's JUICE spacecraft is on its way to Jupiter. Experts like Dr. Geraint Jones have confirmed that there might be a brief window in early November where JUICE could try to image the comet, but the real action will begin in late November or early December. That's when Earth's motion carries us out of the solar glare, and ground-based telescopes can finally get back in the game. When that happens, expect every major observatory to be pointed at that patch of sky, trying to recover the faint, receding visitor. Until then, the only confirmed public detection remains that single, faint stack of images from Perseverance. So, here we are. We stand on the edge of a potentially historic discovery, armed with more questions than answers. The only public evidence of 3I Atlas's Martian encounter is a faint signal teased from public data by curious minds, while the most powerful instruments in the solar system remain mysteriously silent. Is this a simple case of bureaucratic delay and the unforgiving realities of deep space communication? Or is the data so groundbreaking that it requires absolute certainty before being revealed? The truth is locked on a hard drive millions of miles away. What we do know is that the universe sent us another postcard from a distant star, and we are still waiting to read it. Don't forget to like, Rauwans Kremeinstradais, till den subscribe, Rauwak onfine sovri. Dateien scan en boverbine sten, redan spurs, and hit the bell icon for more deep dives into the mysteries of our cosmos. Thanks for watching Space Fact. A rare visitor from deep space is flying through our solar system. The object, now officially named 3I Atlas, is mind-blowingly huge and moving at impossible speeds. Could this colossal traveler from another star hold secrets that could change everything we know about our place in the universe? Some scientists are terrified by what NASA's data is revealing. The breaking discovery. The astronomical community was stunned when the Atlas telescope in Rio Hurtado, Chile detected a mysterious object moving at incredible speed through our solar system on July 1, 2025. Initially designated A11PL3Z, this faint blip at magnitude 18 quickly drew international attention from observatories worldwide. Follow-up observations by multiple telescopes confirmed something extraordinary. This wasn't a typical space rock but the third confirmed interstellar visitor, now officially designated 3I Atlas. Its hyperbolic trajectory and extreme velocity immediately suggested an origin far beyond our solar boundaries, forcing astronomers to reconsider existing models of interstellar object behavior. The object's sudden appearance sparked both excitement and genuine concern within the scientific community, as its unprecedented size and velocity patterns baffled even the most experienced researchers. NASA immediately mobilized its network of ground-based and space-based telescopes to monitor this cosmic traveler closely, launching one of the most intensive observation campaigns in modern astronomy. The extraordinary nature of this discovery has reignited passionate debates about the possibility of extraterrestrial technology passing through our celestial neighborhood, with some scientists expressing private concerns about what this visitor might represent for humanity's cosmic security and understanding of our place in the universe. The discovery story. How does one spot a needle in the cosmic haystack traveling at impossible speeds? Between June 25 and July 1, 2025, the continuous robotic surveys conducted by the Asteroid Terrestrial Impact Last Alert System began detecting an unusual object with properties unlike anything previously recorded in astronomical databases. Located in challenging viewing conditions near the constellations Serpens Cauda and Sagittarius, the object's initial faint appearance made it extremely difficult to track against the crowded star fields near the galactic center. The automated Atlas system's sophisticated algorithms identified this fast-moving visitor, initially catalogued as A11PL3Z, immediately triggering alerts that attracted urgent attention from professional astronomers across the globe. The object's clearly hyperbolic trajectory and extraordinarily high velocity indicated definitively that it was interstellar in origin, prompting an unprecedented level of international collaboration for detailed follow-up observations. Advanced telescopes from the Canada-France-Hawaii Observatory, Lowell Discovery Telescope, and numerous other facilities provided crucial confirmation data, sharing precise positional measurements through secure astronomical networks. This coordinated global effort enabled detailed orbital calculations that definitively cemented 3I Atlas's historic status as humanity's third confirmed interstellar intruder, following the groundbreaking discoveries of 1I Oumuamua and 2I Borisov that forever changed our understanding of cosmic visitors. A stranger in our midst. What makes 3I Atlas so fundamentally different from everything else in our solar system that scientists are genuinely unnerved? This cosmic stranger immediately distinguished itself through characteristics that challenge our basic understanding of interstellar objects and natural physics. Moving at an absolutely staggering speed of approximately 58 kilometers per second relative to our Sun, it dramatically exceeds the velocities of all previous interstellar visitors, including 1I Oumuamua at 26 kilometers per second and 2I Borisov at 32 kilometers per second. Despite its incredible distance, the object maintains sufficient brightness around magnitude 18 to enable telescopic detection and detailed study by major observatories worldwide. Unlike typical solar system objects that follow predictable elliptical orbits, 3I Atlas traces an extreme hyperbolic trajectory with an unprecedented eccentricity of 6.141, mathematically proving it is gravitationally unbound and destined to exit our solar system forever. Perhaps most disturbing to researchers is the object's premature cometary activity, forming a visible coma and distinctive tail despite being over 4.5 astronomical units from the Sun, much farther than any known comet species begins showing activity. This combination of impossible velocity, extreme trajectory, and anomalous behavior has created profound unease among scientists, with some privately questioning whether 3I Atlas represents something far more extraordinary than a simple frozen rock from interstellar space. The predecessors. So how did humanity suddenly transition from never seeing interstellar objects to detecting 3 in just 8 years? Well, our cosmic awakening began with the shocking discovery of 1I/Oumuamua in October 2017 by the Pan-STARRS telescope in Hawaii. This elongated asteroid-like visitor absolutely stunned astronomers with its mysterious acceleration and complete lack of expected cometary features. The enigmatic object sparked some pretty intense scientific debates about whether it had natural or artificial origins, with a few researchers even suggesting it might represent alien technology. The conversation took a new turn with the August 2019 discovery of 2I/Borisov by amateur astronomer Gennady Borisov from Crimea. This time we saw a more conventional interstellar comet that behaved remarkably similarly to comets from our own solar system, giving researchers their first real chance to analyze pristine materials formed around distant stars. Now, the arrival of 3I/Atlas in 2025 marks the latest and most puzzling chapter in this rapidly expanding field, combining disturbing elements from both predecessors while introducing entirely new anomalies. With a significantly larger estimated size than both previous visitors, clear cometary activity, and record-breaking velocity, 3I/Atlas really does defy easy categorization. Each successive discovery has just exponentially expanded our understanding of the galaxy's vast population of wandering objects ejected from distant planetary systems, suggesting a dynamic and, honestly, potentially threatening interstellar environment filled with cosmic refugees from stellar catastrophes. The cosmic journey. So where exactly is 3I/Atlas headed? And should humanity be concerned about its trajectory through our solar system? Well, this interstellar wanderer follows a precisely calculated path that brings it uncomfortably close to multiple planets, though it keeps enough distance to avoid being captured by gravity. It was first detected approaching from a tough viewing angle, which kept it hidden near the sun's glare. The object's hyperbolic orbit will carry it to perihelion on October 29, 2025, passing closest to our star at 1.36 astronomical units. That's roughly 203 million kilometers away. While 3I/Atlas will never get closer than 1.8 AU to Earth, so our planet is safe from any kind of direct collision. Its trajectory aligns almost perfectly with our solar system's ecliptic plane. Astronomers calculate that's only a 0.2% probability of happening by random chance. This suspicious alignment gives the object optimal viewing opportunities of all the major planets, including close approaches to Mars and Jupiter, which would be just ideal for reconnaissance purposes. The path offers some unprecedented opportunities for detailed study by existing planetary orbiters and Earth-based telescopes, but it also raises some unsettling questions about whether such precise planetary encounters could really result from just natural gravitational interactions. After its solar passage, 3I/Atlas will begin its permanent departure from our cosmic neighborhood, carrying whatever information it may have gathered back into the vast emptiness of interstellar space, never to return to our vicinity again. A scientific goldmine. Why are astronomers calling 3I/Atlas the most scientifically valuable interstellar object ever detected, despite their concerns about its true nature? This cosmic visitor presents just unparalleled opportunities for studying authentic interstellar materials and processes with a level of detail and duration we've never had before. With its substantial estimated size ranging between 1 and 12 kilometers in diameter, potentially making it the largest confirmed interstellar object and sustained cometary activity producing analyzable dust and gas, researchers worldwide are really mobilizing to extract maximum scientific value from this fleeting encounter. The object's extended visibility period means that major observatories and space telescopes, including the James Webb Space Telescope and Hubble Space Telescope, can collect high-resolution spectra and detailed imagery over several months, instead of the brief observation windows we're used to with interstellar visitors. Such comprehensive data provide invaluable insights into primordial materials and formation processes from other star systems, potentially preserved unchanged for billions of years during the object's journey through interstellar space. The massive international collaboration studying 3I/Atlas really exemplifies modern astronomy's remarkable capability to rapidly coordinate global resources and expertise when investigating these transient cosmic phenomena. Scientists actually anticipate that discoveries from this visitor could fundamentally reshape our understanding of planetary formation, the prevalence of organic compounds throughout the galaxy, and the dynamic processes that shape stellar systems. All in all, 3I/Atlas is shaping up to be an unprecedented scientific treasure trove, with implications extending far beyond our solar system's boundaries. Unanswered questions. What fundamental mysteries about 3I/Atlas continue to terrify scientists despite months of intensive study and observation? The most experienced researchers admit that critical questions remain frustratingly unanswered, creating unprecedented uncertainty in the astronomical community. Scientists struggle with determining the object's precise dimensions, as the dense coma extending up to 24 kilometers across completely obscures the solid nucleus, leaving size estimates ranging wildly from 0.8 to 11 kilometers in diameter. The object's anomalously early cometary activity, beginning at over 4.5 astronomical units from the Sun, directly contradicts established thermal evolution models for icy bodies, suggesting either exotic ice compositions or unknown internal heating mechanisms. Spectroscopic analysis reveals compositional anomalies that defy conventional explanation, with water-ice signatures that don't match expected patterns and electromagnetic emissions that hint at non-natural materials or energy sources. Perhaps most disturbing is the object's apparent structural integrity, despite an estimated age exceeding 7 billion years of interstellar travel, which should have resulted in significant fragmentation and erosion from cosmic radiation and micrometeorite impacts. Advanced computer modeling has failed to adequately explain how natural formation processes could produce an object with three I/Atlas's specific combination of characteristics, forcing scientists to confront possibilities that challenge fundamental assumptions about cosmic physics and the nature of interstellar space, leaving the scientific community genuinely uncertain about what they're actually observing. The alien question. Could 3I/Atlas represent humanity's first confirmed encounter with extraterrestrial technology? And, why are some scientists genuinely terrified by this possibility? This question has sparked honestly unprecedented controversy within the astronomical community, dividing respected researchers and really challenging the boundaries of acceptable scientific discourse. Prominent Harvard astrophysicist Professor Avi Loeb has courageously argued that the object's statistically impossible trajectory, precise planetary encounters, and anomalous physical characteristics strongly suggest artificial, rather than natural origins, potentially representing advanced reconnaissance technology from an extraterrestrial civilization. Loeb emphasizes that the mathematical probability of 3I/Atlas's trajectory allowing optimal study of multiple planets approaches 0 for random natural occurrence, suggesting deliberate design for comprehensive solar system reconnaissance. His analysis points to the object's strategic timing, noting it remains hidden behind the Sun during closest approach while deploying what appears to be controlled outgassing for course corrections or communication purposes. However, the majority of mainstream scientists express deep skepticism about artificial origin theories, emphasizing the importance of rigorous scientific methodology and warning against premature conclusions that could undermine public trust in astronomical research. Critics argue that extraordinary claims require extraordinary evidence, and current observations, while puzzling, don't provide definitive proof of intelligent construction. Nevertheless, the artificial origin hypothesis continues gaining credibility as conventional explanations fail to account for 3I/Atlas's unprecedented characteristics, forcing the scientific community to confront the, terrifying possibility that we may be witnessing our first confirmed contact with alien intelligence deliberately studying human civilization. Observing the visitor. How are the world's most powerful telescopes being mobilized to unlock the secrets of 3I/Atlas, and what are they revealing that has scientists so concerned? Astronomers worldwide have initiated the most comprehensive interstellar object observation campaign in history, deploying virtually every available telescope and detector system to study this mysterious visitor before it disappears forever. Ground-based observatories including the Gran Telescopio Canarias, Palomar Observatory, and Gemini South provide continuous optical and near-infrared imaging, while space-based platforms such as the James Webb Space Telescope, Hubble Space Telescope, and various planetary mission spacecraft contribute unprecedented high-resolution data across the electromagnetic spectrum. This coordinated international effort involves over 30 observatories and research institutions sharing data in real time, creating the most detailed observational dataset ever assembled for an interstellar object. Sophisticated spectroscopic monitoring reveals temporal changes in outgassing patterns and dust production that suggest controlled rather than random thermal processes, while polarimetry studies indicate surface properties inconsistent with typical cometary compositions. Radio telescope arrays including Arecibo and the Very Large Array continuously monitor for potential electromagnetic emissions or communication signals, though results remain classified under government security protocols. Advanced computer processing analyzes terabytes of observational data searching for patterns that might reveal the object's true nature, with some preliminary results being restricted from public release. The unprecedented scope and intensity of this global observation effort reflects both the scientific opportunity and the underlying concern about what humanity might be encountering in 3I/Atlas. Dawn of a new era. How has the discovery of 3I/Atlas fundamentally transformed humanity's approach to cosmic threats and our understanding of galactic dangers? This latest interstellar visitor marks a dramatic evolutionary leap in our species' ability to detect, analyze, and potentially defend against visitors from beyond our solar system. Advanced automated sky surveys, including the Atlas Network, Pan-STARRS, Catalina Sky Survey, and the soon-to-be operational Vera Rubin Observatory, have revolutionized interstellar object detection from once-in-a-lifetime events into regularly observable phenomena that require constant vigilance and rapid response capabilities. This technological revolution extends beyond simple detection to include sophisticated threat assessment protocols, international coordination mechanisms, and classified defense planning scenarios that acknowledge the potential for hostile interstellar visitors. The Pentagon's All-Domain Anomaly Resolution Office has quietly established new protocols for evaluating objects like 3I/Atlas, recognizing that future visitors might not be as apparently benign as current examples. Future space missions are already being planned to intercept or rendezvous with similar objects, potentially including defensive capabilities should such visitors prove threatening to human civilization. As global scientific and military institutions adapt to this new cosmic reality, humanity stands at the threshold of an unprecedented era where the mysteries of deep space directly impact planetary security and survival. The age of interstellar object research promises to fundamentally reshape not only astronomy and space science but also defense strategy, international cooperation, and our species' long-term survival planning for decades to come, as we finally acknowledge we are not alone in a potentially dangerous galaxy. As 3I/Atlas races toward its October encounter with our sun, carrying secrets that could forever change humanity's cosmic perspective, one thing becomes clear: we are no longer alone in monitoring our solar system. Whether this visitor represents natural wonder or something far more extraordinary, we stand at the threshold of discoveries that may terrify and transform us. Stay tuned to Space Facts for the latest revelations about our mysterious cosmic visitor. Could an object speeding through our solar system from the void between the stars actually be an alien spacecraft? On July 1, 2025, a mysterious visitor designated 3I/Atlas was discovered, sparking a fierce debate. Was it a natural comet, or the first definitive proof of extraterrestrial technology? One prominent Harvard scientist fanned the flames of speculation, while NASA pushed back with hard data. What followed was a clash between radical ideas and rigorous evidence. Let's explore this together. The Atlas discovery in Chile. So how do we even spot these interstellar travelers in the first place? It starts with a constant, vigilant watch of the night sky. The story of 3I/Atlas began on July 1, 2025, at an observatory in Chile. There, a robotic survey system named ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, detected a faint object at an apparent magnitude of 20, making it about 2.5 million times fainter than the faintest star visible to the naked eye. Led by principal investigator John Tonry, the ATLAS system is a NASA-funded project developed by the University of Hawaii, using its twin half-meter telescopes to scan the entire visible sky every 24 hours. When astronomers calculated the object's trajectory, they saw it was following a sharply hyperbolic path with an orbital eccentricity greater than 1, a definitive sign it wasn't gravitationally bound to our sun. Its orbit was an open curve, meaning it came from deep space and was destined to return there. The object was named 3I/Atlas, with the 3I marking it as the third interstellar object ever discovered. It was racing through our system at a stunning hyperbolic excess velocity of 35 kilometers per second, a truly exceptional catch and a prime target for immediate scientific study. Avi Loeb's controversial hypothesis. But what if a new discovery doesn't fit neatly into our existing boxes? This is where science can get heated. Enter Avi Loeb, a Harvard astrophysicist and the head of the Galileo project, an initiative dedicated to searching for evidence of extraterrestrial technology, having previously sparked debate by suggesting the first interstellar object, Oumuamua, could be artificial due to its observed non-gravitational acceleration. Loeb turned his attention to 3I Atlas. He pointed to its early lack of a visible tail and what he described as a trajectory that might eventually show subtle deviations not caused by gravity. In a paper released on the ArXiv preprint server, a common practice for rapidly disseminating new ideas, he proposed his radical hypothesis. If the object continued to show no outgassing, it might be a technological artifact. He even raised the hypothetical possibility of malign intent, suggesting it could use the sun for a gravitational slingshot to alter its course towards an undisclosed target. Loeb was careful to frame this as an intellectual exercise, admitting a natural comet was the simpler explanation. Still, the mere mention of alien technology from a scientist of his stature was enough to ignite a global media firestorm and put serious pressure on the astronomical community to respond. Media sensation versus scientific method. Here's the thing about alien theories. They travel faster than light speed in the media. Avi Loeb's hypothesis for 3I Atlas was sensational. Headlines around the world, from online blogs to major news networks, quickly latched onto the most dramatic elements of his proposal, the possibility of an alien craft with potentially hostile intentions. This created a fascinating public spectacle but also highlighted a fundamental tension in how science works. The scientific method is a slow, methodical process that can take months or even years of observation and peer review before any conclusion is reached. In stark contrast, the news cycle operates in mere hours. The global conversation was suddenly centered on a dramatic, unproven idea while the painstaking work of collecting hard data was just beginning. This put NASA in the position of having to respond not just to a scientific hypothesis, but to a worldwide media event fueled by one of the most compelling questions in human history. It was a classic case of exciting speculation, published on a preprint server before peer review, getting a massive head start on the deliberate evidence-based investigation. This gap between speculation and verification is where misinformation can thrive. NASA's comprehensive investigation. When a claim is that big, you really need the world's premier space agency to weigh in. So how did NASA approach the mystery of 3I Atlas? Well, they didn't rely on just a single instrument. Instead, they launched a coordinated, multifaceted observation campaign, allocating dozens of hours of precious observation time on their flagship observatories. This involved the Hubble Space Telescope, using its Wide-Field Camera 3 to capture incredibly detailed visible light images, and the James Webb Space Telescope, using its NIRSPEC instrument to analyze the object's infrared light for chemical signatures. A network of powerful ground-based observatories, like the Keck Observatory in Hawaii with its massive 10-meter twin telescopes, also joined the effort to track it continuously. This wasn't just about taking pictures. The goal was a deep analysis under the guidance of experts like Dr. Karen Meech, a leading astrobiologist renowned for her work on distant comets. This comprehensive approach was designed to replace speculation with an overwhelming body of evidence. NASA's mission was clear: to determine, with the highest possible degree of scientific certainty, the true nature of this interstellar visitor and let the data tell the real story. Comet behavior confirmed. So what does a comet actually do when it gets close to the sun? The answer to that question was the key to solving the 3I Atlas mystery. As the object continued its journey inward, NASA's array of telescopes watched its every move. The findings were unambiguous. By late July 2025, as it crossed inside the orbit of Mars, 3I Atlas started to behave exactly like a comet. It developed a glowing coma, a fuzzy atmosphere of gas and dust, that eventually grew to over 100,000 kilometers in diameter. Soon after, it began to sprout a tail of dust and gas stretching for millions of kilometers, pushed away from the nucleus by the solar wind. Dr. Lori Glaze, director of NASA's Planetary Science Division, summarized the findings clearly, stating that the object was exhibiting all the classic signs of a comet, reacting to the sun's energy. Its initial lack of a tail was simply because it was too far from the sun for its ices to sublimate. The final verdict from the data was it looks like a comet, and it acts like a comet, so there was no need for an exotic, artificial explanation when a natural one fit the observations perfectly. Chemical composition analysis. Here's what really matters. You can learn a lot about something by the light it gives off. Using a technique called spectroscopy, a team of astrochemists led by a figure like Dr. Stephanie Malam from NASA's Goddard Space Flight Center analyzed the chemical makeup of 3I Atlas. This process is like a cosmic fingerprint analysis, where light from the comet's coma is split into a spectrum, revealing the distinct signatures of the molecules within it. The analysis confirmed the presence of water ice, but it was the other volatiles that were truly telling. They found a carbon dioxide to water ratio of 0.6, nearly double the average for comets in our solar system. The data from JWST also revealed significant amounts of carbon monoxide and traces of diatomic carbon, the molecule responsible for giving many comets their distinctive green glow. Far from being evidence of artificial design, these unique chemical traits told a story of its origins. The high CO2 content suggested that 3I Atlas formed in a brutally cold region of its home star system, much farther from its parent star than where our own comets were born. It was a pristine sample from a truly alien yet completely natural environment. Trajectory and safety assessment. With all the talk of alien technology and malign intent, a critical question had to be answered. Was this object a threat to Earth? The bottom line is a definitive no. NASA's Jet Propulsion Laboratory, or JPL, used the global observation data to refine the comet's trajectory with pinpoint accuracy. Their calculations, made public through the Center for Near-Earth Object Studies, showed its closest approach to Earth would be a distant 1.8 astronomical units, which is roughly 170 million miles. There was never any risk of impact. The comet's orbit was also highly inclined at 60 degrees relative to the ecliptic plane, the flat disk where the planets orbit, meaning it was passing high above the main traffic of the solar system. Its perihelion, or closest approach to the Sun, was calculated to be a safe 1.5 AU, well outside of Earth's orbit. NASA's Planetary Defense Coordination Office was therefore able to declare with certainty that this object posed zero threat. This precise tracking dismantled any notion that the comet could be a danger, allowing everyone to focus on the science. Natural anomalies in cometary physics. But what about the unusual traits that sparked the controversy in the first place? It's important to remember that in astronomy, unusual does not automatically mean unnatural or artificial. Comets, even the ones from our own solar system, are, notoriously unpredictable. To provide some context, NASA pointed to historical examples like Comet 17P Holmes. Back in 2007, that comet suddenly brightened by a factor of nearly 1 million in less than 48 hours, totally shocking astronomers as it briefly became the largest object in the solar system by volume. This was a completely natural outburst, not an artificial maneuver. Cometary physicists like Dr. Michael Kelly from the University of Maryland explain that these events happen when sunlight penetrates a comet's crust and hits a pocket of supervolatile ice, like frozen carbon monoxide, causing it to flash sublimate and release enormous amounts of gas and dust. These anomalies are not evidence of intelligent control, they are actually a normal and expected part of cometary physics. The strange initial behavior of 3I Atlas wasn't a sign of technology, it was a sign that it was a dynamic natural object. Scientific value of interstellar visitors. So, if it's not an alien ship, why is 3I Atlas still such a big deal? Well, because its scientific value is immense. Every interstellar object that passes through our solar system is like a pristine time capsule delivered from another star. These objects carry the unique chemical and physical fingerprints of the planetary nursery where they were born. The high concentration of carbon dioxide in 3I Atlas tells us it likely formed in an incredibly cold, distant region of its home system. Some studies even suggest it could have originated in the Milky Way's thick disk, a population of older stars, making the comet potentially over 7 billion years old, actually predating the formation of our own sun and planets. Scientists could test this hypothesis by analyzing its isotopic ratios, for instance, the ratio of carbon-12 to carbon-13, and comparing it to other stellar populations. That makes it more than just a passing rock. It's a preserved fragment from the dawn of another world, providing invaluable data for our models of galactic chemical evolution. Comparing 3 interstellar objects. Let me explain why having more than one of these visitors is so crucial. By comparing them, we can start to build a bigger picture of the galaxy. 3. I-Atlas was the third interstellar object detected, and it's fascinating how different all three have been. The first, 1E Oumuamua, was highly anomalous, rocky, appearing to have an extreme 10-to-1 aspect ratio, and showing no visible coma, which is what led Avi Loeb to his original theory. The second, 2I Borisov, discovered by amateur astronomer Gennady Borisov, was almost the opposite. It looked and behaved very much like a standard long-period comet from our own Oort cloud, with a chemical composition, specifically a carbon monoxide to water ratio of about 0.3, that was remarkably familiar. 3I Atlas falls somewhere in the middle. It clearly behaves like a comet, but its distinct chemical ratios and light-scattering properties make it stand out as unique. This diversity is exactly what astronomers hope to find. It allows them to test whether the processes that shaped our home system are typical, or if we are, an outlier. In the end, Comet 3. I-Atlas wasn't an alien messenger, but it did bring an incredible message. It wasn't science fiction, but it delivered profound science. It carried the chemical secrets of its birthplace, a star system far from our own, giving us a rare glimpse into the diversity of worlds forming across our galaxy. The real story isn't about a manufactured object, but about the natural wonder of the universe and our growing ability to study it. If you want more deep dives into the biggest discoveries from space, don't forget to like, subscribe, and hit the bell icon. The universe always has another surprise waiting for us. Thanks for watching Space Facts.